Assalamualaikum and hello everyone. So today our group from class J4EM 1101F are going to present to you about techniques of differentiation. So this is our group member. The first one is me, myself is Putra Syawal Aiman. So my teammate is Auni Afia, Parish and Wafi Lukman. So we'll be explaining to you on how to use the technique of differentiation wisely. So let's dive in. So before that, we need to know what does differentiation means. Differentiation is a fundamental concept in calculus dealing with the rate at which quantity provides information about the slope of the function at any given point. So these are the techniques of differentiation. So for the first one is the product rule. So fx equals to u times v. This is when two functions are multiplied. So the next one is quotient rule, which is fx equals to u over v when one function is divided by another. So the next one is sum and difference rule. It is y equals to fx equals to u plus or minus v. This is when function contains plus or minus. So the next one is constant, d over dx times constant equals to 0. This is when the derivative of a constant is 0. The next one is the power, d over dx times x to the power of n equals to nx n minus 1. This is to differentiate the power of x. So the next one is the polynomial d over dx times kx to the power of n equals to knx n minus 1. This is when your function is polynomial. So for the next one is techniques of differentiation but for trigonometrics. So the first one is y equals to sine x. So we need to use d over dx times sine x equals to cos x. So for the next one is y cos x. So you guys need to use d over dx times cos x equals to negative sine x. And for the last one is y equals to tan x. You guys need to use d over dx times tan x equals to sec square times x.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris and today I will show you how I solve question number 2 A and B. So the first question is to find dy over dx for 3x squared sine 2x. First we need to rewrite the equation first. I use a product rule to solve this question. First, I label the 3x squared as u and sine 2x as v. So, after I label the equation, refers to product rule formula, dy over dx is u v prime plus v u prime. So, we need to differentiate u to u prime. So, we will get 6x after differentiate it. And after we differentiate u, we need to differentiate v2. So, after differentiate, we will get 2 cos 2x. After we differentiate the two function, we need to insert our function to the formula. And after we multiply them, we will get the final answer, which means is... Okay, now we move on to the question B. Use chain rule to differentiate y equal to sine times with x cubed minus x squared plus 1. So, we need to rewrite the equation first. After we rewrite the equation, we need to label it, the outer function and the inner function. Okay. Refers to chain rule formula is dy over dx is equal to dy over du times with du over dx. So we need to find dy over du and du over dx first. So for the dy over du, we need to differentiate the outer. For the du over dx, we need to differentiate inner function. Insert our function to the formula. So dy over dx is dy over du multiplied with du over dx. After we multiply it, we will get our final answer x2 3x squared 2x times with cos x cube x square plus 1. This is our final answer for this question.
Alright, now it's time for question 3, implicit differentiation. So the question, so this is the question. So the first thing we need to do is to differentiate the first expression. So this is the expression, power of 2x plus 1. We need to use the chain rule over here, differentiate the outer layer first, and then the inner layer first. The inner layer later. And we get 2 exponential power of 2x plus 1 as the answer. Next, we need to differentiate the second expression. So this one we need to use the product rule because there are 2 terms over here. So identify the u and v. So this u, this is v, using the formula. So v is 10 to y, this is over here. U prime is x to x. U is x squared, and the v is differentiate 10 to y, and we get secant square 2y to dy dx. dy dx is from the y over here, because every time you differentiate y, we get dy dx in implicit differentiation. And simplifying, we get this. Just put over there, and don't forget negative. So differentiate ln xy, then the third term, the third expression. So we can rewrote this as ln x plus ln y from the logarithm rule. Differentiate, and we get 1 over x plus 1 over y dy dx. Just put over here. Now we're done with that. Open this bracket over here, negative bracket. Then we get all the dy dx expression and put it on the left side, and get all the other than dy dx expression to the right side. And don't forget the negative because they go from the left to right side. And then we factorize the left hand side over here. We get this. And all we need to do is now is to just take all this expression and divide on the right side. So there we go. That's the answer. That's pretty simple. So okay, that's it from me. I will pass it to my other colleagues for the last question. Thank you.
Fourth question. The question asks us to use linear approximation to estimate the value of set 15.98 over 3 minus set 4 15.98. Correct 3 decimal places. So first step, we can check our answer by entering this into our calculator, and we should get negative 0.667. First step, we're going to list out the function, and the singular number inside the function, we're going to replace or name it with x. So our fx is equals to set x over 3 minus set 4x. Step 2 is to differentiate our function, and we will get this. So to the third step, we need to find x. So given x is 15.98, and x naught, we're going to get it by rounding off to 60. Now we're going to calculate the change of x, which is the formula is x minus x naught, and we got negative 0.02. Next, moving to the fourth step, we're going to substitute x naught into our function and first derivative function. And for the function x naught, we got negative 2 over 3, and for our first derivative function, we got 1 over 96. Lastly, step 5, we're going to use the linear approximate formula, which is f naught plus derivative f naught times rate of delta x. So just now we already calculate all of this, and we just substitute it. And the answer is that we get is negative 0.667, which is same with our first calculated answer. This is a reminder, but you need to remember to use